Carbon is an energy currency that sustains life on Earth. All creatures, from humans to corn crops to soil bacteria, require it in one form or another. A finite amount of carbon molecules are cycled throughout the planet in various forms. In addition to being a building block of organisms such as plants and animals, carbon can be found as a gas in the atmosphere, dissolved in oceans, lakes, and rivers, and bound up in complex compounds of decomposed material in the soil called humus. Carbon also occurs in forms that are considered less accessible to living organisms. This kind of carbon, informally called old carbon, is found at the bottom of the ocean and in rocks deep below the surface of the Earth. In order to understand how humans interact with the carbon cycle on land, it is first necessary to take apart how different forms of carbon move through different pools. Plants living on land assimilate carbon dioxide from the atmosphere and use it to build and store plant material in a process known as photosynthesis. As they grow and maintain themselves, plants release both oxygen and carbon dioxide into the atmosphere through respiration. Carbon dioxide is also released when animals respire. In order for the planet to have enough carbon currency to support an ever-increasing human population, we have, for the past 150 years, mechanically transferred fossil fuel carbon from deep below the surface to easily accessible pools. Though tampering with the carbon cycle has its drawbacks. Greater carbon in the atmosphere is rapidly increasing the temperature of the Earth through a process known as the greenhouse effect, with documented impacts on the planet's current residents. Soil contains the largest biologically available pool of carbon on the planet. The carbon that gives soil a rich, dark color, commonly known as humus, has long been recognized as one of the most important natural resources available to humans. Without humus, the crops that we depend on could not grow and obtain nutrition. Soil carbon is also the resource that humans most often take for granted. Conventional agricultural practices, such as crop harvesting, frequent tillage, and heavy fertilizer application, remove significant amounts of this useful carbon from the soil through increased decomposition and soil erosion. Carbon released from these practices enters the atmosphere and contributes to global climate change. Scientists are increasingly realizing that a cheap, beneficial way to reduce carbon emissions lies just below the surface. Think of it this way. Carbon in the soil humus can remain there for hundreds of thousands of years. Given the magnitude of carbon in the soil pool, even if 6 to 7% more carbon can be retained in soil humus through better land management practices, we can offset the amount of carbon being burned through fossil fuels, reducing the intensity of global warming. In addition, increased soil humus promotes greater crop production, water retention, nutrient cycling, and soil decomposer